Hey everyone, this is Big Face from Big Face Robotics. This week I've been doing a bit of this. And what I've ended up with is a rewired Arduino Nano circuit. I had a few changes from the original design and the testing design that I was using. I've now got the RGB LED hooked up to 3 analog outputs, PWM outputs of the Nano, so I can drive the LED through its full spectrum of colours. And I made a few other minor changes to the layout on the prototype board. So my aim for this week was to get the RGB LED working and changing colours with commands sent from the attached PC. So I've used this project as a good excuse to try something new in Python, and that is using wxpython or wxpython, I'm not sure of the pronunciation, to create the interface for controlling the robot. So here's the setup. I've got the interface running on the PC, which you can't see on the camera particularly well, but there's 3 sliders, one for red, one for green, one for blue, and as they're moved they're sending commands or values out to the robot for each of the RGB values between 0 and 255. And I've got a little colour patch on the screen that's showing what colour is expected at the robot LED. And I'll have to apologise, this doesn't come out particularly brilliantly on camera, but we'll give it a go. So if I slide the top slider, red, and you can see the LED colour change, and the little colour patch on the screen changes as well. Same is true for the green. So I can slide that up all the way, and the LED will reflect what the colour is showing on the screen. Same for blue. I can make various combinations of the 3 colours. So that's working quite nicely. You have to take my word for it, that looks better in person than on the screen. But for now, it's working quite nicely. So I'm doing a bit of work getting the servos working, and the aim of this project really was to make a nice simple robot, nothing too complicated. So having thought about it, I've decided to get rid of the potentiometer feedback from the servos, and I'm just going to send commands to the servos to go to a position without the feedback loop. I found, although I could tweak the control loop, it was never perfect and you'd always get that bit of oscillation from the servos, and this is a much simpler method. What it does mean though is you can't move the robot by hand and get the position feedback. You're relying on the position you send to the servo to be the position that it's in, which for this little project should work just fine. So I've written a bit of code for the Arduino that reads in an angle command for each of the servos, and it will convert that to a millisecond set point, and will increment the current millisecond signal being sent to the servo until it reaches its position. And I've got this running here, and the movement's quite nice and smooth. It goes to where it needs to and stops nicely. And this also made it very easy to change the speed of the servos by running the loop that increments or decrements the millisecond value. Just changing the frequency with which that loop runs will slow or speed up the servo. So if I put these down to the slowest that they will go at the moment, you get a nice slow movement. If I put it up as fast as it will go, it's quick, maybe even a bit too quick, quicker than I'll need, I think. So I'll take you over to the PC and we'll have a look at what's happening on the screen as I'm moving these servos around. So there we go, it's a bit rough and ready at the moment, it's just functional, nothing pretty at the moment. I've got a slider for the pan, a slider for the tilt and a slider for the speed. So I can adjust this and that will send a signal out to change the speed that the servos are running at. And if I slide these around, it'll move the robot. And this, the text boxes, are feedback from the Arduino as to the current output being sent to the servos. So you'll see that changing as I move the slider around. If I actually put the speed right down and move the set point, you'll see it counting up until it reaches its set point. So although I haven't got direct feedback from the servo positions, I've still got real-time feedback as to where the servos are currently as they're moving. And from playing around with this and testing, it looks very robust and accurate. And for this project, probably a better way of doing it than using the potentiometer feedback to position the servos. So that's it for this video. Slow but steady progress on this project. We've got the RGB LED working. I can select any colour that I choose from the interface on the PC, and I've figured out the way that I want to run the servos and still maintain some feedback to see what position they're in. So the next step in this project is going to be to start reading some images from the camera and displaying them in a wxpython display. I'm not sure how to do that yet, but I'll figure it out, and I'll be using OpenCV to do some image processing. I'll probably do my standard approach of getting the camera to detect a coloured object, a ball or something, and have the head track it. That's always a good test, shows that everything's working. And at some point, when I'm sure of how I want this circuit to be, I do want to convert this to a more permanent solution. I haven't decided yet whether I'm going to design and etch a board for it, or just use some strip board and make a prototype board that way. That can then be attached to the rear of the robot back here somewhere, and make the whole thing a little bit more permanent and tidy up the wiring. So that's it for now. Hit like and subscribe down below to join me next time. Thanks for watching.